The control signals table is shown. It's composed from 16 different states. Each state has its own control signals. In state 1, we will set the values that we mentioned previously, and here we will set only the value of NOR to 16 for the simplification of our explanation. Then in state 1 and 2, there will be the input of X and Y. The locations 000, 001, 010 are for the NOR, X, and Y respectively, and the other control signals are don't care signals. In state 3, the computer system will read the value that is saved in the location 011 by enable reading it, and then pass it through the ALU and the shifter and enable outputting that value. In state 4 and state 5, the control signals are don't care signals except WE and OE, both are O. In state 6, the computer system will enable reading the value saved in the location 100, decremented by 1 by choosing 001 of the ALU and pass it through the shifter by setting it to 00 and then return them back to the location 4. In state 7, the computer system the control signals are don't care signals except OE and WE, which are both O. In state 8, the computer system will read the value saved in location 101, which is the value of the result, and pass it through the ALU. Then it will shift it to the left and replace 0, and then return it back to the same location. In state 9, the same thing will happen, but with the value saved in location 4, which is the value of the BTL. In state 10, the computer system will read the value saved in location 000, which is the value of NOR, and then decrement it by 1 by choosing or selecting the ALU 210 to 010, and then pass it through the shifter by setting it to 00 and then return it back to the same location. In state 11, the computer system will read the value saved in location 001 and then pass it through the ALU and then rotate that value, and that means it will choose the value of X and then rotate it and return it back to the same location. In state 12, the computer system will choose the value saved in location 101 and then pass it through the ALU and then shift it to the left and replace 1 in the shifted bit and then return it back to the same location. In state 13, the computer system will choose the values saved in location 100, which is the value of the result, which is the value of BTL, and the value of the location 010, which is the value of the denominator, and then decrement the denominator from the BTL by setting ALU 210 to 011 and pass them through the shifter and return the result back into the location 100, which is the location of BTR. In state 14, the computer system will multiply the value saved in location 101, which is the value of the result, by the value saved in location 110, which is the value of the dot counter, and then multiply them by setting ALU 210 to 100 and then pass them through the shifter by setting SH10 to 00 and then return them back to the location 5, which is the location of the result. In state 15, the computer system will output the value saved in location 101, which is the value of the result, pass it through the ALU and the shifter, and enable outputting that value through the gate. So after the simplification of the next state table, we will get the values of Q3 next and Q2 next, or D3 and D2. Q3 next is equal to 1 whenever Q2 or together with the Q1 bar or QO bar ANDed together with Q3, or Q1 ANDed together with the QO or together with Q1 bar and QO bar and NOR is equal to 0, and the whole is ANDed together with the Q2. The values or the value of Q2 next is equal to 1 whenever QO bar is OR together with Q3 X NOR Q1, or PTL is less than Y ANDed together with Q2 or Q1, and the whole is ANDed together with the Q2, or is equal to 1 whenever Q3 is ANDed together with the Q1, or Q3 bar is ANDed together with the Q1 bar and Y is not equal to 0 inverse, and the whole is ANDed together with the Q1. The value of Q1 next is 1 whenever Q3 bar ANDed together with the QO and the whole is ANDed together with the Q2 bar or Q1 bar, or Q3 and Q1 and the whole is ANDed together with the Q2 or QO bar, or is equal to 1 whenever Q2 ANDed together with the Q1 and the QO bar, or Q2 bar and the Q1 bar and the QO, or Q3 bar ANDed together with the Q2 bar or the QO bar and the whole is ANDed together with Y is not equal to 0 and Q1. The value of QO next is equal to 1 whenever Q3 is ANDed together with the Q2 bar or QO bar and the whole is OR together with the QO bar, which is ANDed together with either the Q2 X NOR Q1 or Y is equal to 0 Q2 bar, Y is equal to 0 ANDed together with Q2 bar or Q1, or NOR is equal to 0 inverse ANDed together with the Q2 or Q1 bar and the whole is ANDed together with the QO bar as we said, or is equal to 1 whenever Q2 and the Q1 bar and the QO bar ANDed together with MSB is equal to 1. So after the simplification of the control signals table, we will get the values of the control signals. The control signals are as shown. As you see, S1 is equal to 1 whenever Q3 OR together with the Q2 or a Q1 or a QO. SO is equal to 1 whenever Q1 X NOR with the QO OR together with the Q3 or Q2. WE is equal to 1 whenever Q3 is OR together with the Q2 bar and the whole is AND together with the Q1 bar or QO bar and the whole is OR together with the Q3 and Q2 bar, or is equal to 1 whenever Q1 ANDed together with the QO bar. WAA2 is equal to RIA2 and both are equal to 1 whenever Q2 is OR together with the Q3 and Q1 bar. WAA1 is equal to 1 whenever Q2 is ANDed together with the Q1 and Q3 bar is ANDed together with the Q2 bar and Q1. WIAO is equal to 1 whenever QO is ANDed together with Q3 bar or Q1, or is equal to 1 whenever Q1 is OR together with QO bar and the whole is AND together with the Q3 and Q2, or is equal to 1 whenever Q3 is ANDed together with the Q1 bar and QO bar. RAA1 is equal to 1 whenever Q3 bar is ANDed together with Q2 bar. RAAO is equal to 1 whenever Q1 is ANDed together with QO, which is OR together with Q3 and Q2, and the whole is OR together with Q3 bar, or it's equal to 1 whenever Q2 bar is ANDed together with Q1 bar and QO bar. RBA2 is equal to ALU2, and both are equal to 1 whenever Q3 or Q2 or Q1 are together with QO bar. ALU1 is equal to 1 whenever Q2 ANDed together with the Q2 ANDed together with the Q1 bar and QO, or Q2 bar ANDed together with the Q1 and QO bar. ALUO is equal to 1 whenever Q3 bar is ANDed together with the Q2, or Q3 is ANDed together with Q1 bar and QO. SH1 is equal to 1 whenever Q2 bar is OR together with QO bar and the whole is AND together with Q1 bar. SHO is equal to 1 whenever Q3 is ANDed together with the Q1 and the whole, with the QO, and the whole is OR together with the Q1 bar and the whole is ANDed together with Q2 bar. Output enable is equal to 1 whenever Q3 XNORed with the Q2 and the whole is ANDed together with Q1 and QO. RBE is equal to RBA1 and both are equal to 1. RBAO is equal to 0.